The general solution of equation dy over dx equals to minus x upon y. Apply variable separable method. So we have y dy equals to minus x dx. Integrate with respect to x or integrate this equation. We will have y square upon 2 equals to minus x square upon 2 plus c, x square upon 2 plus y square upon 2 equals to c. Now replace c with 1 upon 2 a square. We have x square plus y square equals to a square. Equation 1 is the correct answer. The differential equation associated with the primitive y equals to ax square plus bx plus c. Primitive means a solution of which one differential equation. For suggestions we have, as y equals to ax square plus bx plus c. In this equation or solution we have three constants a, b and c. These are arbitrary constants. So order of differential equation will be the number of arbitrary constant, and we have three arbitrary constant. That's why option C will be correct. The degree of this given differential equation is y dy over dx equals to x dy over dx square plus x is. We have to find degree. Higher degree coefficient, higher order or higher degree coefficient, differential coefficient, higher order differential coefficient is dy over dx, and its power and its max power is 2. That's why 2 is the degree. The orthogonal trajectory of a family x square minus y square equals to a, where a constant is given by. So differentiate with respect to x, 2x minus 2y dy over dx equals to 0, minus 2y dy over dx equals to minus 2x, minus 2 cancel out by minus 2. We have y dy over dx equals to x upon y. For orthogonal trajectory, replace dy over dx with minus dx over dy. We have minus dx over dy equals to x upon y. Now apply variable separable method. 1 upon y dy equals to minus 1 upon x dx plus c. Log y equals to minus log x plus log c. Log x plus log y equals to log c. It means that xy equals to c or y equals to c upon x. Option B is correct. Let W be the subspace of R4 spanned by three vectors 1, 3, 5, 10, 1, 0, 2, 4, 1, 2, 4, 8. If these vectors, we are checking how many vectors are linearly independent because of number of linearly independent plus spanning set form basis. So this is spanned by these three elements. If we are able to find how many elements are linearly independent, then number of linearly independent becomes a dimension of W. Apply elementary row operation on this matrix. We have first row as it is 1, 3, 5, 10, second row 0, minus 3, minus 3, minus 6, and third row 0, minus 1, minus 1, minus 2. At this stage, row 2 and row 3 are in proportional. That's why rank of this matrix is 2. Rank is 2. It means that there are two linearly independent rows in a given matrix or column. So dimension of W is 2. Option B is correct. The order of the permutation is, to find order of permutation, first write the permutation in the disjoint cycle. 1 is going to 8 and 8 is going to 1. First cycle closed. 2 is going to 2. 3 is going to 6. 6 is going to 4 and 4 is going to 3. 5 is going to 7 and 7 is going to 5. All symbols has been used. So order of this permutation is LCM of disjoint length of disjoint cycle. Length is 1, 2, 3. So LCM of these three elements are 6. That's why option C is correct. 4 vectors 1, 1, 0, 0, 1, 0, 0, 1, 1, 0, A1 and the last vector 0, 1, AB. These 4 vectors are linearly independent. They will be linearly independent when rank of this matrix is 4. And rank of this matrix will be 4 when each row contains pivot. Each row contains pivot. Apply elementary row operation. This matrix equivalent to first row. There is no change in first row. Second row 0, minus 1, 0, 1. Third row 0, minus 1, A1 and the last row 0, 1, AB. Again apply elementary row operation. Equivalent matrix will be 1, 0, 0, 0, 1, minus 1, 0, 0, 0, 0, A, and the last column will be 0, 1, 1, B plus 1. Now try to make this entry 0. What we have? First column will be 1, 0, 0, 0, 1 minus 1, 0, 0, 0, 0, A0 and the last column 0, 1, 1, B. If this entry is 0, then the third row will be 0, 0, 1 and the last row will be 0, 0, B. These two are in proportional, so it will be, you can make this entry 0 by elementary row operation and rank of this matrix will be 3. Rank of this matrix will be 3, but it is given that rank is 4 indirectly, means linearly independent. So A not equals to 0. If A not equals to 0 and B becomes 0, if B becomes 0, then again rank of this matrix will be 3. So B also not equals to 0. It means A and B both are not equals to 0. Option B is correct. Determine which of the following matrices have the same row space. Same row space matrices have same rank. So we are trying to find out the rank of the given matrices E, F and G. First matrix is 1 minus 2 minus 1, 3 minus 4, 5. Apply elementary row operation. We will get equivalent matrix as 1 minus 2 minus 1, 0, 3 2 is 6, 2 and 3. So we are getting 2. So rank of this matrix is 2. Rank of matrix E is equals to 2. Now we will check rank of second matrix. F 1 minus 1, 2, 2, 3 minus 1. Apply elementary operation on this matrix. We have 1 minus 1, 2, 0, 5 and minus 5. Again we are getting rank of F is 2. Now try to find rank of G. After applying elementary row operation, first row is same, second rows is like S 0, 1, 4, 0, minus 2, minus 5. So first pivot element, second pivot element and third pivot element. If means rank of this matrix, because these two are not same or in proportion, that's why rank is G is 3. So E and F are the same row is space. Option A is correct. The number of elements of order 3 in the group Z6 cross Z15 means we have to find number of elements of order 3 in the direct product of these two groups Z6 and Z15. So in direct product, order of an element, suppose AB is an element belonging to this group, then order of this element is equals to LCM of individual elements, means order of A and order of B. So we need to find elements of order 3. It means we need LCM 3. So whenever we can get LCM 3, when order of A is 1 and order of B is 3, when order of A is 3 and order of B is 1, and the order of A and B both are 1. So how many elements of order A? How many elements of order A in Z6? Because of order 1, because of 1 divide 6, that's why number of elements is 1, and order 3 of order 3 in Z15, because of 3 divides 15, that's why 5 3. So we are getting 1 into 2. There are two elements of order 2. In this case 2 into 1, again we are getting 2 elements, and in this case we are getting 2 into 2, sorry, 2 2 into 2, 4. So total number of elements we are getting of order 3, 2 plus 2 plus 4 means 8 elements are of order 3. Option B is correct. The number of 7 silo subgroup in a group of order 392 we can find easily with the help of silo theorem. First factorize 392. So 2, 1, 9, 6, 2, 9, 8, 2, 49, 7 and 7. So 392 can be written as 2 raised to the power 3 into 7 square. Number of 7 silo subgroup can be found using this formula 1 plus 7k divides equals to 1 plus 7k, where 1 plus 7k divides the order of group, means 2 raised to the power 3 into 7 square. We know that 1 plus 7k doesn't divide 7 square, that's why 1 plus 7k will divide 2 raised to the power 3, where k equals to 0, 1, 2 and so on. So value of k equals to 0, then n7 is equals to 1. When value of k is 1, then 8. So either 1 or 8, 7 silo group of 7 silo subgroup in a group of order 392 exist. Option D is correct. We have to find limit of given expression. To solve this problem, we will use the concept of definite integral as the limit of sum. For this, I can write this problem as limit n tends to infinity summation running from k equals to 1 to n, 1 upon n, and 1 upon 3 plus k by n Using definite integral, I can write lower limit as 0 and upper limit as 1. How I could find lower limit? So lower value of k upon n means 1 upon n, and 1 upon n is going to 0, and upper limit, upper value of the summation n upon n means 1. So 0 to 1, replace 1 upon n as dx and k over n as x. So we have 1 upon 3 plus x dx, and integration of this expression is log 3 plus x, and limit from 0 to 1, we will get log 4 we will get log 4 minus log 3, and this one can be written as, using logarithm formulas, log 4 upon 3. That's why option A is correct. Matrix A of this size 9 cross 9 and satisfying the condition a square minus a equals to 0. So its annihilating polynomial will be x square minus x equals to 0, or this is annihilating equation. So we have x minus 1 are factors of this. So if we write minimal polynomial, so what are the possibilities of minimal polynomial? X and x minus 1, because of these are in linear factor. As you can consider, these are linear, that's why matrix A is diagonalizable. Option D is correct. And a square minus a equals to 0. It means that a square equals to a, means a is idempotent matrix, and we know that eigenvalues of idempotent matrix are 0 and 1. 0 and 1. Option A must be a 0 matrix. It is necessary, it is not necessary A must be a 0 matrix. If you consider 1 1 0 0, suppose this is a, then a square equals to a, but a is not a 0 matrix. Option A has been discarded. A is an identity matrix. No, this is again wrong. Rank of A is either 1 or 0. You can consider rank of this matrix is 1, but if you consider another matrix like 1 1 0 0, this is again matrix A by our consideration and satisfying a square equals to a, and rank of this matrix is 1. So rank may be 1 or 0, we are not sure about it. Option C has been discarded, so correct option is only D. The dimension of the subspace of M2 cross 2 is spanned by these three matrices, means vectors are in the form of matrices. For this, we write equations for these three matrices, that will be 1 1 2. This is first entry of the matrices. Now minus 5 1 minus 4, second entry of the first row, and the third is minus 4 minus 1 minus 5, and the last 2 5 7. Now apply elementary row operation and try to find out how many rows contain pivot elements. There is no change in first row. 1 1 2 0, 5 plus 1 6, 10, 10 minus 4 again 6, 0 3 1 0 3, 3. So you can observe these two rows are in proportional. So you can delete anyone. So after deletion we have 112, 066 or 031, and the last row is 000. Rank of this matrix is 3. Rank of this matrix is 3. It means there are 3 independent row or columns in the given original matrices. So option C will be correct. If the rank of the matrix A of this size 7 cross 5 is 5 and rank of matrix B of this size 5 cross 7 is 3, we have to find rank of AB. To find rank of AB, we know the result. Rank of AB is at most mean value of rank A, comma, rank B, and greater than equals to rank of A plus rank of B minus common value, as common value is 5 because of 5 is responsible to make a multiplication of these matrices. So rank of A is 5, rank of B is 3 minus 5 less than equals to rank of product of AB less than equals to 3 because of rank of B and A is 5 comma 3 and mean value is 3. That's why we are getting 3 less than equals to rank of AB and less than equals to 3. So this last inequality implying that rank of AB is same as 3. Option B is correct. The sum of eigenvalue of this given matrix you can find easily with the help of determinant of A minus lambda I equals to 0. You can solve this equation and you can find exact eigenvalue of this given matrix. But there is no need to find exact value of the eigenvalues because of we need to tell trace of this given matrix A. Suppose this is a matrix A equals to sum of eigenvalues, and sum of eigenvalue will be minus 1 plus 3 and minus 3. These are neutral, so minus 1 is the value. Option A is correct. The minimal polynomial of this given matrix, if we consider this matrix as a block matrix, so first block is 2 0 1 2, second block 2, and the third block is 5. You can identify block in given matrix as like this. So minimal polynomial of this matrix is equals to minimal LCM of minimal polynomial of blocks. So LCM of the first block is 2 0 1 2, and minimal polynomial is x minus 2 whole square. Minimal polynomial of this x minus 2, and minimal polynomial is x minus 5. Minimal polynomial of first block could not be x minus 2 because of x minus 2 doesn't annihilating this, because x minus 2 doesn't annihilate 2012. Means if we put this first block into this matrix, into block polynomial, then we couldn't get 0. That's why x minus 2 is whole square, because of upper triangular matrix and eigenvalues are diagonal elements. So we need to find LCM of x minus 2 whole square, comma x minus 2, comma x minus 5. Need to take LCM. So write factors of each term. So x minus 2 into x minus 2 next x minus 2 and x minus 5. So how to find LCM? This x minus 2 comes once, x minus 2 comes again, and x minus 5. So x minus 2 whole square into x minus 5. Which one option is giving this information? Option C is correct. 4 vectors 1 1 0 0, 1 0 0 1, 1 0 a1, and the last vector 0 1 ab. These 4 vectors are linearly independent. They will be linearly independent when rank of this matrix is 4, and rank of this matrix will be 4 when each row contains pivot. Each row contain pivot. Apply elementary row operation. This matrix equivalent to first row. There is no change in first row. Second row 0 minus 1 0 1. Third row 0 minus 1 a1, and the last row 0 1 ab. Again apply elementary row operation. Equivalent matrix will be 1 0 0 0, 1 minus 1 0 0, 0 0 a, and the last column will be 0 1 1 b plus 1. Now try to make this entry 0. What we have? First column will be 1 0 0 0, 1 minus 1 0 0, 0 0 a0, and the last column 0 1 1 b. If this entry is 0, then the third row will be 0 0 1, and the last row will be 0 0 b. These two are in proportional, so it will be, you can make this entry 0 by elementary row operation, and rank of this matrix will be 3. Rank of this matrix will be 3, but it is given that rank is 4 indirectly, means linearly independent. So A not equals to 0. If A not equals to 0 and B becomes 0, if B becomes 0, then again rank of this matrix will be 3. So B also not equals to 0. It means A and B both are not equals to 0. Option B is correct.